So today we're going to cover, like I said, we're going to cover, there's a couple different methods for calculating volume. The first one is called the disk method, okay? Um, and that's what we're going to do. We're going to do today, maybe tomorrow, well, it depends when we finish this, okay? And there's two more ways to calculate volume, and then we're done. Okay, then we are done with the chapter. Okay, so it's not a lot in this chapter, but it is important because a lot of these, there's definitely going to be multiple choice questions on the AP test dealing with volume and area, and sometimes they'll throw in a FRQ or two dealing with this. So this is definitely something we want to hit. Okay, so before we get to it, we've had stuff like that, right? We've had stuff like that, right? Where we had a function and area under the curve. That's area. What's the difference between that and volume? That's my first question. Like, what's the difference between how are volume and area different? Just in concept, in the idea of it. What's the difference between area and volume? Volume is three-dimensional, yeah. That guy right there is two-dimensional, right? It's got a length, it's got a width, right? What's the third dimension? When you go see 3D movies, what's the difference between a 3D movie and a regular movie? What's the only difference between a regular movie that you go see or a 3D movie, which you got to put glasses on and pay extra money to go see? What's the difference between those? Why does it cost more money to see a 3D movie than to see just a regular movie on a big screen? What's the difference? Mhm. Comes at you, right? Comes at you. There's the third dimension, right? So this guy right here doesn't come at you. This guy has a length, it has a width or a base or a height, whatever you want to call it. Doesn't come at you. So the first question is, where is the volume? All right, because you can look at the questions we have here. Look at this first question here. That's two dimensions, right? That's two dimensions. Um, so where does the volume come into play? Well, the volume comes into play with these words here. So if you look at these words here, it says volume. Obviously, we know what we just talked about volume. Solid revolutions, solid revolutions. Solid, a solid is something that's solid, right? Something that's 100% made, it's solid. Three-dimensional. Solids are three-dimensional. And they're made by making what's called revolutions. Revolutions. Okay? So today we're going to do the disk method. So I'm going to show you how these things are shaped. Okay? So let me see, I put a link here. The link there is for a video. And I'll show you the video right now. Okay, so it doesn't have any sound to it. It's just a picture. Okay, let's see if I can get it bigger. Okay, that's big enough. So this is two dimensions, right? This is two dimensions. We've been doing area under the curve, right? So we could find area under the curve from 0 to whatever that is there, right? We've been doing that, right? So how are we going to find volume if it's two dimensions? Well, watch this video. This video will show you what they talk about with revolutions. Okay, this is what they're doing. You see how that's called a revolution. Anytime it goes all the way around, right? It's creating an object which is now three-dimensional, right? So this part here, I should say the radius here, the radius is coming out and going in. That's part of the revolution. That's what they mean by revolution. So every time it makes a revolution, it creates that shape. Okay, looks like a cup, kind of sideways cup thing. Okay, so that, and then what we're going to do today is we're going to use what's called the disk method. So you see on the inside here, there's like a disk. So it's a solid disk, right? The edges are kind of reddish and the inside is a light blue. We're going to calculate using what's called the disk method. What the disk method says is we're going to find the volume of one and then use that to find the volume of each, because this is made, this shape here, this side kind of sideways cup kind of thing, is made up of a bunch of these disks. So we're going to use that to calculate the volume. Okay. So first thing we need, these are the things that we need. That's the dx part, that's the x part. That's the radius there. The yellow part, that's the radius. Okay, here's another one. They'll show you. This one's kind of a cone shaping thing. The function was originally 2x, 2 times the square root of x. But this is how the shapes we're looking at. You're never going to see the shape when you do a problem. When you do a problem, you're never going to see the shape. But you kind of have to do this mental math or mental gymnastics of what it looks like. And that's, believe me, that's the hardest part about this thing. The hardest part is imagining what this looks like, because you're looking at something. You're looking at something like this, and you're like, okay, find the volume of this. There is no volume. So you got to kind of do that mental gymnastics thing where you kind of picture in your head what it would look like if it did that, what I just showed you. Okay. So there's videos on YouTube of that, of creating those 3D shapes, but they won't, like on problems, they won't show you. They'll just describe to you what's happening. Okay. But that's kind of like what it's doing. That's the 3D shapes that we're creating. Okay. So the important parts today. The important parts today of calculating. First of all, our formula here. This is the formula we're going to use. Okay. The formula we're going to use is what's called, this is the disk method. So we're going to use pi first. Pi is on the front. Pi is in the front. Okay. A to B, wherever the bounds are, we got to find the radius. The radius. So the radius goes from, like, what's the video here? Let me show you the video one more time, or just stop the video on the first one. The radius is going to be the distance from the edge, right? The edge is out here or down here, to the center of the revolution. Where is it revolution? Where is it revolving around? Which is the center? In this case, the center was the x-axis. So the radius would be from the function square root of x to 0, right? Y equals 0. Okay, so that's what we got to do first. We got to figure out, that's what they're talking about when they say radius. Okay, and then there's two kinds. There's a dy and there's a dx. When do you know if you do dy? When do you know if you do dx? It's pretty simple. If you're horizontally, so horizontal is side to side, right? So that guy you just saw, that's a dx. Okay, if you go this way, if you're revolving this way, if you're revolving over a horizontal line, it's a dx. Always going to be a dx. If you're revolving around a vertical line, it's a dy. Okay, it's easy to tell. And once you know, like if they say you're revolving around the x-axis, okay, the x-axis is a horizontal line, dx. If you're revolving around x equals 2, x equals 2 is a vertical line, right? X equals 2 vertical lines, so that means you're going to be revolving around this way, okay? So the radius is top minus bottom, right? Top minus bottom. Just like the video showed, the top and wherever you're revolving around, okay? And the radius is right minus left for dy, okay? All right, so let's jump into one. These aren't that bad as long as you follow this. As long as you follow this page here. This page here is going to be your guide. Okay? It's not that bad. It's not that bad. Okay? Okay, so kind of one of the shapes we just looked at, right? Let R be the area enclosed by the function f of x and the x-axis and the vertical lines x equals 0 and x equals 5. Okay? So it's closed off. That green area is closed off by f of x on the top, on the bottom, the x-axis, and on the sides, it's closed in by x equals 0 and x equals 5. Okay, that's what makes that green area. It's enclosed. Find the volume of the solid generated when R is revolved around the x-axis. You may use a calculator and round to the nearest thousandth. Okay, so it's a calculator question. Sometimes these will be, sometimes these won't be. Okay, so the big part is to label it. Okay, the first part is to label it. F of x. So this guy right here is, let's see, f of x equals 2 root x. That's that guy right there on top, that curve. The only curve line on there is f of x. Okay. This dotted line is x equals 5. The x-axis is x, or the y-axis is x equals 0. And then this is y equals 0. Those are everything they've given me. Right. So the next thing I got to do is figure out which way this thing is revolving. Is it revolving around a horizontal line or is it revolving around a vertical line? I have two vertical lines. I have x equals 0 and x equals 5. I have one horizontal line, y equals 0. So you got to figure out where it's revolving. They'll always tell you, but you got to look. Okay? So you go to the word revolved around the x-axis. The x-axis is the horizontal. So that's dx. So this guy is going to be a dx because it's going to revolve around a horizontal line. Okay? All right. So that means this green guy here, this line here that makes f of x, this line here, when it starts revolving, it's going to come out. It's going to come out and then go back in and then go all the way around once. It's going to create a solid, right? It's going to create a picture just like you saw, that little cup, that little sideways cup. Okay, that's what it's going to create. That's the solid, right? It'll be thicker in the mouth part and then skinnier in the bottom of the cup, right? That's what it's going to create. Okay, is it important to see that shape? No, not necessarily. Some people can't. I mean, it's just it's all the part in your brain that develops last is the part of being able to visualize things and see things that are abstract. The abstract kind of making things that aren't there appear in your head. That's the part in your brain that develops last. For some people, it develops early. For some people, it doesn't develop early. Doesn't mean it's not a sign of intelligence. It's just it doesn't develop yet. So some people are like, yeah, I can see it pretty easy. Some people are like, I can't. It doesn't matter. Okay, I just show you those videos just to show you what we're finding volume of. Okay. Okay, so we got that. We know which way it's revolving. We know what it's going to look like. So now we're going to find the volume. So volume is right here. So we're going to write that guy. We know it's dx because it's revolving around a horizontal line. Okay. So volume equals pi. And then we have radius squared dx. Okay. So we got to fill in a couple things, but that's essentially what our template's going to be. Okay. Let's start with the bounds. So we know how it's revolving. So where is the top? Where is the mouth? So when it revolves, right? When this thing revolves, comes out, goes in, comes out, goes in. What are the bounds going to be, right? Bounds are left to right on this guy because it's dx. So what are the bounds going to be from where to where? 0 to 5. So we got 0, we got 5. Okay. So I'm going to go past 5 It's not going to go less than 0. Okay. Now, I don't want to say this is the hardest part, but it's the part that gives students the most difficulty. So now the radius, right? The radius. The radius of this guy, when it revolves, right? It's going to go from here to there, right? Or it's going to go from here to there, right? The radius changes. The radius is always from this part to this part here, right? The distance from that part to that part there, right? That's the radius. But the radius is changing because this shape is curved. It's not always the same, right? On a circle, the radius is the same everywhere because it's a circle. On a sphere, the radius is the same everywhere because that's the definition of a sphere. Equal distance from the center, right? This guy isn't, right? The radius here is over 4 units. The radius here is 2 units. So the radius isn't going to be a number. It's not going to be a number. But how would I calculate this distance? So the way you find radius is, if I wanted to find the distance, how long that area was, that segment is right here from right here to right here. How would I do that? If I wanted to find the length of that segment there, it's about 3.6, maybe 3.7, 3.8. But how would I find the distance here? How would I do that? You ready? I would plug x value into f of x, right? I would plug it in here to find this, right? And then what would I do? Because that would tell me here, right? That would tell me where that was. But then don't you have to know how the length is? Now the length is 0, I understand that. But you want to subtract it from the bottom, right? The bottom is 0. I know the bottom is 0. But pretend the bottom wasn't 0. You would need to subtract it from the bottom, right? That's going to be the length of the radius. The length of the radius is going to be from the top. So the top is 2 square root x to the bottom. The bottom is 0. Okay, the bottom will always be 0. The bottom will not always be 0. If it is 0, great, it is 0. But the bottom's not always going to be 0. So just be careful with that one. Okay, it's got to have that minus part. A lot of people leave this part off because they assume it's 0. It's not always going to be 0. Okay, all right, so really, we don't need that 0. You don't really need the 0. You can write it like this. This problem, this specific problem, not all problems, but this specific problem, you can write like that. Right? This is a calculator question, but really you don't need a calculator because you're just going to square it. It's going to be 4x dx because you square everything on the inside. 2 squared is 4. The square root of x squared, or the square, x squared squared. The square root of x squared is x. So there, and then you can do it that way. I mean, it is a calculator question. So, I mean, really the only part we're going to need the calculator for is pi because they want us to round. Okay, so it's going to be 4x squared divided by 2. And then, pi times that from 5 to 0. So we have pi. It's really 2x squared from 5 to 0. Plug in 5, plug in 0, see what you get. So we get pi times 2x squared pi times 2x squared So 5 squared is 25 times 2 is 50 pi. And then since you're multiplying by 0 in the other one, everything's gonna cancel out. So everything is just gonna be 0. So you get 50 pi. On a multiple choice test, that would be good enough. But since in this case they want you to actually, it says round to the nearest thousandth, now we got to use the calculator to figure out what that's going to be. Okay? Or you can plug in you could do this different ways. If it's a calculator question, you can use a calculator on anything. You can do it from the very beginning. But since it was a pretty not complicated question, you can see on the next one, you're going to get a little more complicated. Okay? So I'll do it both ways. I'll show you. Okay, so we're going to go pi. I'll do it the long way, and then I'll do it let's see, nope, math. And then I go 0 to 5. And then on the inside, I have 2 times the square root of x. You can put a -1. It doesn't hurt anything to put a -1. The only thing here is that you're going to need to put a squared because it's squared. So you got to insert other parentheses. And then square it. Dx, which is the same as 50 times pi. Okay. So when you round to the nearest thousandth, because they want you to round to the nearest thousandth, the thousandth is 3 spaces. Thousandth is 3 spaces, 9. Okay, so the number after it is 6. So that means I'm going to round up. So 0.0, so 157.080. Okay. All right. Okay. Okay, so here we go. Let's do the second example. Example, the second one that has f of x is e x plus 1. Okay. First thing you do when you read this problem, now I gave you graphs because these are your notes. But you can see on the next problem, they don't give you a graph. The next 2 problems, they don't give you a graph. More than likely, they're not going to give you a graph. If it's a test, they're not going to give you a graph. It's important to draw the graphs if it's not given, to see what you're actually doing, to see what the radius is. It's a lot harder. It's not a sign of intelligence if you can do this in your head. I have a lot of students that think, oh, I'm super smart. I should be able to do this in my head. No, okay? That's not, a sign of intelligence is doing it correctly, okay? Not trying to do too much in your head. Draw the picture. Draw the picture if they don't give it to you. Draw the picture and do it from there because it's a lot easier to see. It's a lot easier to see, okay? Don't make a difficult problem even more difficult by trying to do things in your head that you don't need to, okay? So they give you f of x. They say f of x is e to the x plus 1. The horizontal line, y equals 1. And the vertical lines, x equals 0 and x equals 2. Find the volume of the solid generated when r is revolved around the line y equals 1. Okay. You may use a calculator and round to the nearest 10th. All right. So the first thing is let's label everything that was given to us. So first thing, We got f of x. So the curve is f of x equals e to the x plus 1. We have a vertical line, x equals 2. We have another vertical line, x equals 0. And then we have a horizontal line, y equals 1. Okay. I label it so that I don't have to think about it later. It's already there. So this guy is going to revolve around y equals 1. It says revolve around y equals 1. Y equals 1 is a horizontal line. So that means it's going to be another dx. Okay. So let's set this up. Dx. Okay. Okay, so now bounds. Bounds look like it's going to be this. It looks like the bounds, the left and right bounds, since this is dx, looks like it's going to be 0 and 2, 0 to 2. The radius now, the radius. So the radius is from the top function to the bottom function, or the top function to the function it's revolving around. That's how you find the radius for dx. You go to the top function. Where's the top of the green stuff? To the bottom of the green stuff. Okay? And you draw a line. That's what I do. I always draw a line, or some sort of line, from the top of the green stuff to the bottom of the green stuff. The top is going to be the first one. I write, that's the first one, e to the x plus 1. The bottom is going to be the minus part on the other side, right? This one's not minus 0 because it's not y equals 0, it's y equals 1, okay? So the top is e to the x plus 1 minus the bottom, which is positive 1 this time, okay? The ones are going to cancel out. The ones are going to cancel out, so you'll get e to the x dx squared, I should say. Squared still. Okay. It is a calculator question, so you can do it by hand or you can do it by calculator after that. That's all I need to see. That's all the work I need to see there. If it's a calculator question, this is all the work I need to see. If it's not a calculator question, then you need to keep doing it by hand. Okay? So since this is a calculator question, let's go to the calculator and figure out some volume. Another mistake I see a lot is forgetting that pi. A lot of times you forget about the pi in the beginning. Your answer doesn't come out. And trust me when I say this, if you have a multiple choice question, the answer with pi and the answer without pi are going to be there. Because again, the people who make these tests know where students make mistakes. They're called distractors for a reason. So make sure you don't forget the pi. We go from 0 to 2. We're going to have e to the x squared. So e that's not the e I want. E to the x power. Close oops, no. Delete. There we go. Close parentheses and then square it. So it's really e to the 2x. That's really what it is. Close it. Enter. There you go. 84,192. 192. Make sure you round correctly. Okay? Make sure you round correctly, because if you're off a little bit, that could be the difference between a right answer and a wrong answer. So make sure whatever it says to round, round to. Okay? All right. Okay, let's see. Okay. I might be able to finish these today. Okay, so Let's look at the next one. Let's look at the next one. The next one doesn't give you a graph. So the first thing I'm going to do after I read it is I'm going to graph it. I'm going to put the graphing. Anything they told me, I'm going to graph it. Doesn't have to be a fancy graph. Rough graph is fine. Don't have to have straight lines. Just give yourself a mental picture. Okay? So the first thing I'm going to do is I'm going to make a graph. Okay? So we have y equals 1/2 x is going to be revolving about the y-axis from y equals 0 to y equals 4. Okay, so let me draw those. Y equals 0 and y equals 4. Y equals 0 is the x-axis. Y equals 4, 1, 2, 3, 4 is this line here, the two red lines. Y equals 4, y equals 0. Okay, and then now the actual, now I'm going to draw 1/2 x. 1/2 x. So it's going to, so it just has a slope. It's a line. It's going to go up 1 over 2, up 1 over 2, up 1 over 2. Okay, so 1, 2, 3, 4, up 1 over 2. Oops. Up 1 over 2. Okay. So find the volume of the solid formed by revolving around about the x-axis. Sorry, about the y-axis from 0 to 4. From 0 to 4. Here's my question. Where is the bounded area? Because I don't have any bounded areas anywhere. Where is the, so we know, where is it revolving around? Like what is, because we have to have a bounded area like we did before with the green stuff, right? The green ones before, you had the green here, that was bounded, right? Bounded on all sides, right? Same thing with one before. I got it not bounded. So what do I got to do? There's no areas there that are bounded. Because unless I can figure out where they're bounded, then I can't figure out my bounds. I don't know what the radius is going to be. So what do I do? How do I figure out where it's bounded? Yeah.
You do it in respect to line bounded from 0 to 4.
Yeah, I see that, but my picture's not bounded. So what do I do? Yeah. hmm Yeah, no. So you guys are doing the problem already. I'm not even there yet. I don't have a bounded region, right? I don't have an R, an area, right? That's where I'm at. You guys are a little bit past me. I haven't even got to the volume yet. Where's my bounded area? That's what I'm asking for. Which is the bounded area? Like, because this can't be the volume area because it got out, right? Right. Think of a bounded area like a gated fence, right? Like a gated area. Like in my backyard, it's gated. I have fences everywhere, so my dog can't get out, right? Here, this is not gated. He can get out there, right? It's not gated. On this side, it's not gated. He can get out there. So that's what I'm talking about. Where is the bounded area going to be here? Because it says it should be bounded. What do I do? Because unless I found that bounded area, that's going to be my radius. Y equals 4. So plug in 4 here. And then that'll tell me X. Oh, I see what you're saying. Yeah, that's what I was trying to get at. Just keep drawing the thing. You just keep drawing the thing, right? We stop there, but you keep drawing it. That was my point. You know what it's going to be. Draw a picture that until you bounded something, right? So we know it's going to be here. We know it's going to be here. We know it's going to be. Two, 3, 4, 5, 6. So change colors. This guy's growing very, very slowly. So eventually it'll go there. Eventually it'll go there. There, now I have a bounded region. Okay, because I'll see that a lot of students, they just stop drawing it. And I'm like, where's your bounded region? Like, what? It's got to have a bounded region, right? So the bounded area here is this part here. Can't get out, can't get out, can't get out. It's bounded, right? That's my green area. They labeled it green before, so I'll label it green as well. Okay. Okay, so go back to what I was doing. Y equals 1/2 x. Let's see. And then I'm revolving about the y-axis. Revolving about the y-axis. What is the y-axis called? What is the actual name of the y-axis? The y-axis is a nickname. What is its actual name? Good. Okay. So it's revolving about the y-axis. The y-axis is a vertical line. So it's going to be revolving this way. It's going to be revolving this way. Hey. Oh, okay. What type of shape is going to make? Can anyone see that? What type of shape is it going to make when it revolves? Mm-hmm. Yeah, kind of a wide cone, right? Kind of a wide cup cone kind of thing, right? This is the mouth here, and then it'll kind of look like that, right? Okay. All right. So this is a dy. Okay. Oops, wrong way. Dy. Okay. When I'm looking for the bounds, where do I look at? When I'm talking about bounds, where do I look at here? Mm-hmm. Right to left, top to bottom. That's what I'm asking for. Yeah. Make sure you go back and look here. Right? When you're looking at bounds, these is a radius. Okay? I didn't put bounds here. I should have put bounds. Bounds here, when you're looking dy, bounds are going to be top to bottom. When you're looking here, it's going to be right to left. So put that in your notes because that's going to be very important to know, to remember. Okay? I don't want you, don't, if you don't write it down, you're going to have to memorize it. Okay? So top to bottom. Top to bottom are going to be the bounds. Okay? Okay, the last part. Radius. Radius. This part was in the notes. For dy, this part was actually in the notes here. We go right to left. Right minus left. Right minus left, right? Bounds are bottom to top or top to bottom, however you want to look at it. But radius is right to left. Okay, radius is right to left. Okay, so what's the right side? What's the left side? Hmm? And the left side is 0? What's the problem with that? I agree. I agree. The blue is the right. The left is 0. I agree there. One of them's okay. One of them's not so good. Yep. Yeah, this is y equals, right? I have to solve it for x equals. Yeah, that's the only difference. So y equals 1/2 x. So solve it for y. So multiply both sides by 2. So you get 2y equals x. So instead of 1/2 x, you're going to put 2y. How about 0? 0 okay? Or do I have to do something with 0? Is this part okay here? Or do I have to put anything, change anything there? Is 0 okay? Because I hate for you to find out on test day. So help me out here. Because I hate for you to get next week to the test and you're like, oh, wait, I changed that one, but do I change this one? And sit there and stare at it and stare at it and stare at it and stare at it. And the answer won't come to you because we didn't talk about it. So let's talk about it right now. Is 0 okay? It's already solved for x. It says x equals 0. Okay? It's okay. These guys aren't, but we don't need those in terms of the radius, right? The radius is from right to left. Okay? All right. This one might be easier to do by hand until the very end because it's got y's. How do I do y's on my calculator? How do I do y's on my calculator? Doesn't have x's. How do I do y's on my calculator? All right, let's do it by hand then. Okay. So this is going to be volume equals pi 2, 0, 4y squared dy. So you find the antiderivative. You're going to go 4y cubed divided by 3. So 4y cubed divided by 3. And you're going to go times pi, sorry, from 2 to 0. Make a pi times, and I got 4/3 x cubed minus pi times 4/3 x cubed. So for one of them, I'm going to put in a 2. For one of them, I'm going to put in a 0. Bounds from 0 to 4. Oh, yeah. For some reason, it got erased. Mine got erased. Yep, thank you. And I thought it was a 2. So 4. Change these. 4, 4. Okay. 4 cubed is 64. 64 times 4 is 216, I think. Let's see. 64 times 4 divided by 3. Okay, so 256 divided by 3 pi. And over here, cancels out 0. $256 divided by 3 times pi. Oops. I get 268.083. Okay. All right. Oh, this one didn't even say it was a calculator question, so we couldn't even use the calculator on this one. Unless it says it's a calculator question, we can't use the calculator. So, okay. The last problem. Okay, so I want you to do the last problem on your own. The last question on this assignment. Doesn't say anything about a calculator, so we're going to assume it's a non-calculator question, so you can't use the calculator for anything. Okay, so just use the information in there to solve it. Okay.